Okay, so if you're new to the cloud or where you haven't run containers on AWS before, this video will break down how to use the Amazon Elastic Container Service. So we'll talk about the differences between, say, running Lambda versus running ECS tasks or ECS services, or just hosting on a virtual machine on EC2. So I'll show a breakdown of when you should do which and why we go with ECS here. After that, we'll create a cluster. I'll talk about the two different types of cluster being Fargate or EC2, and then we'll create a task and we'll create a service, and I'll show you how those are provisioned. Okay, so here's a great chart that I found on fortheorem.com. I'll leave a link in the description. I'm not affiliated with them. I just found their site. But this chart, I'm not going to break it down exactly, but it kind of differentiates when you should use which, from starting on the left with on-premise all the way over to AWS Lambda and the different options we have. So what you'll see here is we kind of, like it shows at the bottom, you have custom versus commodity. So it's basically you're giving up control by moving from on-premise to EC2 and EC2 to ECS, those sorts of transitions from left to right. You give up control, but in giving up that control, you make it easier to work with. So in this case, we're going to be talking about EC2, ECS, which this shows ECS on EC2, or Fargate. We're just going to lump that all together for this part, and then I'll talk about that later, and then AWS Lambda. So the benefits here are really going from EC2 into ECS means that we can have a containerized approach. You could do containers in EC2 as well, but with this containerized approach, we can now do it on ECS where we have created per task or per job, and then we can have that serverless compute that we only pay for what we need, rather than EC2 where you might be setting up auto scaling groups to get that same functionality. The next option here would be EKS. So same thing here, except it's kind of like we're provisioning our own compute. So EKS is very similar to running as ECS on EC2 in that we are provisioning our compute where our job will be run, the job being the container that gets provisioned and then deprovisioned. But with Kubernetes or EKS in this case, there's a lot more setup that we have to do. So if you have very large applications that have a lot of different moving pieces, that might be the way you want to go. But it is a large upfront cost of engineering hours to get that built out. Whereas we could set up ECS on EC2 within 10 minutes of this video. And then lastly, AWS Lambda. So you guys are probably familiar with Lambda if you're watching this. This should really be your small, like if you're a programmer, they're just functions. They should do one thing. They should be quick. The timeout is 15 minutes, so it should be under that. But realistically, most of them are going to be under a minute or 3 minutes tops. Once you start getting into those bigger workloads, that's where you want to shift back into Kubernetes or ECS. And so the next important concept that I want to cover here, and then we'll go back to the Lambda, is a task versus service within ECS. So task is basically aligned to a container. You can think about when you're creating a task, you are creating a container. Just like in Kubernetes, if you're creating a pod, you're creating one or more containers, but the task associates containers just like a pod associates containers. A service, however, is a long-standing application. So we might have a service that spins up tasks, say our web server that you don't want to take offline. So we might have a web server task cut. So we might have a web server service and then an application or API service, and these are long running. But then you might have a task that your API endpoint is to, let's say, generate some kind of math cut. But then say you have one of our applications has a PDF generation. So you might have an API that's long running as a service and it has two different containers that are running, but then you want to have an API call that will generate a PDF, and that is a task because it is a create and then destroy all in, say, 15 minutes or so. So we have our API that does not go down, but then we have our task that gets created, and you can think about these as something with an exit. So like I'm going to run a Python command that will exit at some point and return a response. So if you use Python to run at web server, you run python app.py and it just holds. It just says serving traffic on port 3000. Whereas if you do Python hello world, it says hello world and exits. So that's how you can think about the difference between service and task here. And so inherently from that, you can see that using a service in place of a Lambda is not really applicable. Certain places maybe, but like if you're serving a web server, you can't do that over Lambda. You could replace a whole API server with a Lambda, but I wouldn't recommend doing that. But obviously you can do a breakdown of that into API gateway and multiple Lambda functions. But really, the difference here is the task versus Lambda function when you should do that switch. So really, the benefit here is just the timeout on Lambda. If you have a job that is running over 15 minutes, if it even risks going over 15 minutes in like a successful entry, then you should go with ECS. The the Lambda timeout is a hard stop. You can't go over it. You could always do Docker containers on Lambda if you have like a 3-minute task, and that's fine. You will get better startup periods with that because Lambda has a warm up pool. But with ECS on Fargate, there is no dedicated warm runs. They're always cold starts. So if you're not familiar, it's basically when we run Lambda or run ECS, it pulls the application code onto a dedicated compute server that AWS runs for us. That will take longer on Fargate. So expect like a 60-second startup time from the time that you click run task to the time that it actually starts, and that will never get quicker. Whereas if you do that on Lambda, it might be 60 seconds to run the first one, and then it could be 5 the second time because the application code is on the instance where it's running. And this gets highly technical, so I don't go too much in depth. Drop in the comments if you want more in depth on that, and I can make a little short about it, but I'll also leave some documentation on that. Okay, so let's stop with the theory now, and let's go ahead and actually build something. Let's go ahead into ECS in the console here, and I'm just going to create a cluster. I'm going to call this ECS demo cluster. And I'm going to leave those as default. So what you'll see here, we have Fargate as our option, which is serverless, or Amazon EC2. So it's basically, do we want to bring our own servers, or do we want to do the pay-as-you-go type of model where we only pay when our service is running or a task? So I'm going to do Fargate. That's usually what you're going to do, but in really large applications, you might use EC2. There are some benefits again, because you get that manual configuration. This also, when you run on EC2, you can enable that warm start. So basically, if we're running a container that's sitting in ECR, every single time we run that, Fargate has to pull that image. So if it's a gigabyte, that's like 20 seconds every time you run it. Whereas if it's on EC2, you pull that one time and now it's cached locally on that instance, and then it's there and every job can pull that image that already exists locally. So again, though, we're going to go ahead with a serverless version for this one. And all of this stuff's optional. I'm just going to go ahead and leave it. You can set up container insights. I would recommend that in a production cluster so that you can see what's going on and change your compute and memory as needed. But we're going to go ahead and create. And now this is going to take a second to create. But while that is creating, I'm going to go over to task definitions and create a new task definition. And we will call this ECS task. So I'm going to do a task and I'm going to do a service. And again, we're going to do Fargate. We will leave this as Linux. Let's go ahead and create a new role. And for our image, so I'm going to try and use this Docker IO Alpine image. And we'll do Alpine container port. That should be fine. We don't need any private registry authentication because we're not using one. This is public. CPU, we don't need any environment variables, but you can just configure them as key value here if you need it for your job. And in here, so I would not recommend doing this in a production grade. Set your command as what you need, but I'm going to do an override here, and I'm going to do echo hello, just like we saw there. So this should just run a container that echoes hello world and then exits. And otherwise, that looks good. Let's go ahead and create. Okay, so now that we have our task definition made, this basically defines what we want to do, what type of job we want to run when we run one, and then we can invoke that definition that creates a container. So let's go ahead to deploy, and let's do run task. We're just going to do one task. We don't have a group. There's our cluster, and we will just leave that as is. Yeah, so this all looks good. Just go ahead and create. And again, there's a lot you can do here. So like if you're in a some kind of enterprise environment, or you have an RDS database you're connecting to, something with anything related to networking, you can set up each pod to get its own network interface within your virtual private cloud. And then you connect with whatever you need inside of there. So you can set up your virtual private endpoints, whatever you really need there. That's all possible with these containers on Fargate. So what we'll see, I went and created it, and it says deprovisioning, so let's go make sure it actually ran. Oh, I turned off the logs. Let's try that again. So I'm going to turn on logs now. Let's go ahead and deploy this again. Run task. Now I'm not surprised that it said deprovisioning so quickly, but we couldn't see the logs of the echo. But this should only take half a second. So you'll see it's provisioning, and that's where it's going to pull the image in. Status is running now, and there we go. There's our hello world. So that's where you can see this is our task, and then if I come back here to my tasks that are running, you'll see if I update, it's now stopped. So I paid for the quick half a second that that container ran, and that's it. So that's the benefit here. Realistically, you should be using Lambda for something like hello world, but if you have a task that takes, say, an hour, that's where this is really good because you can get that consistency of the containers, but also build it in an environment with ECS so that you know that you're only paying for what's needed. And then, of course, there's tons of other things you could do with this. You could set up a Lambda function to invoke this. You could use step functions, SQS, whatever you want to kind of pipeline it and stream out whatever input to output you need for your containers. So now that's a task where we run it once, it runs, does its job, and then deprovisions. Now we're going to do a service. So I go back to task definitions, going to create a new task definition, and we will call this service. Same settings here, going to leave all of that the same. And let's see, I have this image here. I'm going to call it hello, and this will be on port 80. This will be a web server. Again, going to leave environment variables all as default for now, not too worried about any of that. And I'm going to go ahead and save that. And now I will deploy. This time I'm going to do create service. And so this will create a service with my container. Just going to do one replica in here. And then what we could do, so like if I was running this as a production server, I could do multiple replicas, AZ rebalancing. And then again, this is where I could set up all of this for a VPC. I could do a load balancer to it, all of the things to make it really production ready. But I just want to show off the ECS service in this case. So, and also service auto scaling. That's a massive thing that you should know about. But I will go ahead and create this. And the reason that service auto scaling is so important because it's a lot easier to auto scale with these containers and putting your load balancer in front. No, cut that. So there we go. We see very quickly our task is active and it looks like it is pending. So while it's in this pending state, there's a lot of stuff that goes on. It has to pull the image from whatever repository it's in. And then there's a lot of stuff that AWS does because they're managing this compute, basically figuring out what's the best compute on their systems for our job to be running. So that's where it can take like up to 60 seconds really. But so the task is running. So let's go ahead into here and let's see, we have a public IP here. Let's go ahead and open that. I'm going to throw HTTP in front to make sure. And so it is loading. I think this has 1 gig of memory, so it's loading very slowly. But on the opposite side of this, we should see a service that says hello that is the Nginx demo container. I don't know if this is going to load. I'm going to leave that. You can assume that a random Nginx site just showed up. Again, whatever website you're hosting or API, any other thing that you're doing that's a long-standing process that does not have a certain end date or end time or end after this procedure. If it's just long running, that's where you want to use services. So now this, I could just leave this. It'll run until I tell it not to. So I'm going to go ahead and stop this now. And that kind of concludes what a service is.